To this studio. Today we want to look at work test examples for homogeneous linear differential equations with constant coefficients. And last time we looked on how to solve homogeneous linear equations. Today we want to further our studies on the topic. Kindly subscribe if you have not subscribed. You also remember to share with your friends so that they may be able to get this knowledge. So welcome. We will look at some different examples. Remember, you can get roots in different ways. You can get distinct real roots. You can also get solutions with repeated roots. You can also get roots with complex roots, solution with complex roots, and you can also get so basically those are the key ways that you can get solutions for a given homogeneous equation. So we'll take first the first example, like the one that gives us distinct real examples. So for example, you are given this equation here. So if you look at this equation, you are given some initial conditions. We share that one and this one. So if we are given this this equation here, how do we solve it? How do you solve this homogeneous linear differential equation? So if you look at the coefficients here, they are constants. For the second derivative, the constant is 1. For the first derivative is -7. And we have 10. So A is 1, B is -7, C is 10. Those are the constants. Now let's see how we do this. So you have to introduce the lambda. You introduce lambda, the coefficient. So we have this. This equation, we call it a characteristic equation. We call it a characteristic equation. Hello. Nice of you. Okay, so we call this equation characteristic equation, or we can also use the term auxiliary. So if you end up talking about auxiliary equations, I'm talking about this equation with this lambda. So if you look at this equation resembles much of this equation here, general equation. So it's like we are substituting the y to lambda. So that is second derivative we square. Then -7 first derivative, like that. Then plus 10. So this is power 0, so it's 1, then is equal to 0. So that's actually what we are calling auxiliary equation. So we solve this, and it will give us values of this lambda. So you'll find this is the value is 2 or 5. The first lambda, so 1 is 2, and the second is 5. So we have those two roots. Remember, to solve these, we are basically applying the idea of quadratic equations, and factorization, then equating, and so on, or using quadratic formula. I have a tutorial for that. You can also check on it up there in the previous tutorials. So the general equation for two distinct roots is actually given by this. where C1 is the first constant and C2 is the first constant. Then we are substituting the lambda half there. So the first lambda, first root is 2 and second root is 5. So the general should be y equal to C1 e lambda 1x plus C2 e power lambda 2x. So if you substitute them, you'll find this is the answer. That's the answer. So if you look at our equation, which is y second derivative, you'll find that the highest power, the highest derivative is y1 is second. We have second derivative and first derivative and second derivative. So we just solve that from our initial condition. We only have condition for first derivative. So that's the reason that we are going to differentiate to get the second derivative of y. From our initial conditions, we can get the value of y, and we can also get the value of first derivative, and we can also substitute the values of x. So when you substitute the values of x, like in the first case, x is 0, so you'll find this equation reduces to this. Then the second equation here reduces to this, because our y is 23, is a first derivative, and x is 0. Then you solve this simultaneously. Remember also I covered a tutorial on how to solve simultaneous equations using different methods: elimination, substitution, and by also matrix method. So you can also look at the video up there, the tutorial that I did on that. So you'll find that the constants is C3, constant 1, and second constant is 4. So that you can be able now to get the particular solution after substituting this to the general equations, to this general equation. So you have lambda 1, these are the first root, lambda 2 the second root, and you know the value x is general, so you leave it there. Then you know C1, the first constant, second constant. When you substitute, you get that as the solution. That's the solution. If you have any question on this, kindly leave a comment. Okay, next step, let's look at a case whereby we have the roots being repeated roots. So we have this question here, and we have the initial conditions given here. Remember what we said about this condition: y into bracket 0 equal to 2 implies or means x is 0 when y is equal to, when x is 0, y is equal to 2, and same case for the derivative there. So what we need to do here, we need now to introduce to get the auxiliary equation, or what we are calling characteristic equation, and we introduce that lambda. They have seen how we do this. You solve this using quadratic method. And you'll find that the two roots which are repeating, first root is 2/3, 2/3, and the other one is 2/3. So that's repeated roots. That's what we mean. So general solution for repeated roots in given differential equation is given by this: y equal to, into bracket, first constant plus second constant times x, e to power lambda x. So our lambda we know is 2/3, so we just substitute it down here to 2/3. Then after that, that's the general equation. Now we want to get a particular equation. So from the condition given, we see that we have the first derivative. Therefore, we differentiate once. We differentiate our equation once, our general equation once, so that we get this. Then after that, we substitute what we know from the initial conditions. From the initial conditions given, which are these ones. When we substitute that, we'll get simultaneous equations. Then we will be able now to solve for C1 and C2 simultaneously, and you will find this is the answer. So which kind of simultaneous equation do we expect here? The first one, when x is 0, y is 2. So we expect to have this kind of equation. We expect to have C1 plus C2 x, okay, into brackets our lambda is 2 thans x. You know x is 0, of course. So if this x is 0, substitute by 0 here, this becomes 0, and this also becomes 0. So you can see we are having C1 being equal to 2. So it just goes direct. Then the next one, you substitute same way, and you substitute the value of C1. So if you substitute the C1 as 2 here, clearly you can see you are getting y when y as first derivative is -1 when x is 0. So what do we have here? When x is 0, this is -1, so you have -1 equal to 2 thans C1 2 okay, 2 plus C2. So you can see that, and you can see this is 4 over 3, and then you solve. When you solve, you automatically read to this. So if you have a question on that, kindly leave a comment. I'll be able to reply to you. So that after substituting C1 and C2 and lambda, you find the particular solution for that, or D is actually that. Next, let's look at solution whereby you are getting the roots to be complex. So we are given this kind of equation here. Remember this equation here, that one we have here, this D we don't have, it's not initial value problem, so we don't have conditions. So here we expect to just get general solution. So getting auxiliary equation, that's true. Solving quadratically, you'll find you are getting complex root. So one is negative and the other one is the conjugate of the other. So what's the general solution for this? It will be in that form. Where alpha, in this case our alpha is actually -3, and our beta is actually 4. Our beta is actually 4. So what we are left with is getting the values of C1 and C2. But for us to get C1 and C2, we need some conditions. But in our case here, we don't have the condition. So that becomes the solution for that. So refer your friends to this channel. It's very indicative. I'll be tackling everything piece by piece like this. And my objective is to make sure everyone understands all the to the latter. So kindly subscribe and remember to leave a comment. And if you have any question from your class, from your friend, from your revision, leave it there. I'll do it for you. Okay, bye. Until next time.